NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will add and subtract rational expressions step by step, focusing on finding common denominators and combining numerators carefully. Example A. We want to compute 1 over b plus 4 over 3b. The key idea: use a common denominator. Since the second term already has 3b, we rewrite 1 over b as 3 over 3b. Then we add numerators because denominators match. Example B. Now subtract 4 over 3x squared y minus 3 over 2xy. Step 1. Find the least common denominator. Here, it is 6x squared y. To get there, multiply the first fraction top and bottom by 2 and the second fraction top and bottom by 3x. Then combine the numerators over the same denominator. Example C. Subtract a plus b over a minus a plus b over b. The common denominator is ab. We rewrite each fraction to have denominator ab, then combine the numerators. After that, expand and simplify. Finally, we can optionally factor the difference of squares. In this lesson, we will simplify two algebraic expressions step by step, focusing on smart common denominators, factoring, and clean cancellations. Let's begin with example 1. Example: we will simplify the sum of four rational expressions in x and y. First, observe a key factorization. Y to the fourth minus x to the fourth equals negative, open parenthesis, x to the fourth minus y to the fourth, close parenthesis, and x to the fourth minus y to the fourth factors as x squared minus y squared times x squared plus y squared. So our natural common denominator will be open parenthesis x squared minus y squared close parenthesis times open parenthesis x squared plus y squared close parenthesis. Let's rewrite each term over this common denominator carefully. Combine the 4 into a single fraction over the common denominator. The numerator is sum of the adjusted numerators. Now expand the numerator and combine the denominator. The numerator is sum of the adjusted numerators. Now expand the numerator and combine like terms step by step. X times x squared plus y squared gives x cubed plus xy squared. Y times x squared minus y squared gives x squared y minus y cubed. Then minus x cubed minus y cubed plus x squared y minus xy squared. Factor the numerator as 2y times open parenthesis x squared minus y squared close parenthesis. Then cancel the common factor with the denominator. Great. Now example: we will simplify a product that contains a fractional term. Distribute the factor a squared plus x across the bracket by first combining the terms in the bracket over a common denominator. The bracket becomes the sum of open parenthesis a squared minus x close parenthesis times a squared plus x plus 2x squared, all over a squared plus x. Then multiply by a squared plus x to cancel. Now expand the product a squared minus x times a squared plus x. That equals a to the fourth minus x squared. Add 2x squared to get a to the fourth plus x squared. To recap, in the first example, we identified a smart common denominator. The expression is 1 over a squared minus 1, plus 2 over a squared plus 2, a plus 1, minus 2 over a plus 1. Start by factoring each denominator as squared minus 1 factors as a minus 1 times a plus 1, a squared plus 2 a plus 1 factors as a plus 1 quantity squared. The least common denominator is a minus 1 times a plus 1 squared. We rewrite each term with this common denominator. Since they share the same denominator, we can combine them into a single fraction. The numerator will be a plus 1 plus 2 a times a minus 1, minus 2 times a squared minus 1. Now expand the numerator carefully. 2 a times a minus 1 becomes 2 a squared minus 2a. Negative 2 times a squared minus 1 becomes negative 2 a squared plus 2. Notice that positive 2 a squared and negative 2 a squared cancel. In the remaining terms, a plus 1 minus 2 a plus 2 simplifies to 3 minus a. The simplified result is 3 minus over a minus 1 times a plus 1 squared. Remember the restrictions. A cannot equal 1 or negative 1 because they make denominators 0. Recap. Factor denominators, choose the least common denominator, convert each term, combine the numerators, expand, cancel like terms, and simplify. In this lesson, we will add and subtract rational expressions by factoring, building a common denominator, and simplifying step by step. We'll work through one example together. Here is our problem. We will simplify the expression by following a clear sequence of steps. Step 1. Factor any quadratic denominators. Here, x squared plus 2x minus 3 factors as left parenthesis x minus 1 right parenthesis times left parenthesis x plus 3 right parenthesis. Now rewrite the expression using the factored form. Step 2. Build a common denominator of left parenthesis x minus 1 right parenthesis times left parenthesis x plus 3 right parenthesis and rewrite each term. Step 3. Expand the numerator and combine like terms. Step 4. Factor the numerator, x squared plus 5x minus 6. That factors as left parenthesis x minus x squared plus 5x minus 6. That factors as left parenthesis x minus 1 right parenthesis times left parenthesis x plus 6 right parenthesis. Step 5. Cancel the common factor x minus 1, remembering it is not allowed to be 0. So x cannot be equal to 1, and x cannot be equal to negative 3 from the other denominator factor. The simplified result is left parenthesis x plus 6 right parenthesis over left parenthesis x plus 3 right parenthesis. Example. Here is the expression we will simplify. Step 1. Notice the denominator a cubed minus 1. Factor the difference of cubes using the identity. A cubed minus 1 equals a minus 1 times a squared plus a plus 1. Step 2. Rewrite the third fraction using the factorization we just found. Now the third denominator becomes a minus 1 times a squared plus a plus 1. Step 3. Use a common denominator of a minus 1 times a squared plus a plus 1. Convert each term so they share this common denominator, then combine into a single fraction. Step 4. Expand the numerator. First, multiply a plus 5 by a squared plus a plus 1. That gives a cubed plus 6, a squared plus 6, a plus 5. Then, subtract 6 times a minus 1, and subtract 6 times a squared plus 2. Step 5. Distribute and combine like terms. Minus 6 times a minus 1 becomes minus 6 a plus 6. Minus 6 times a squared plus 2 becomes minus 6 a squared minus 12. Now collect like terms. Step 6. The entire expression becomes the numerator a cubed minus 1 over the denominator a minus 1 times a squared plus a plus 1, which is also a cubed minus 1. So the fraction simplifies to 1, as long as denominators are not 0. Therefore, the simplified value of the expression is 1. Great work! The big ideas were factoring a difference of cubes, using a common denominator, and combining like terms. In this lesson, we'll simplify a rational expression by finding a common denominator, rewriting each fraction, combining numerators, and then factoring and canceling common factors when allowed. Let's move step by step and visualize each move clearly. Step 1. Write the original expression. We will simplify the expression. 1 over x plus 3x over x plus 1 minus 1 over x times x plus 1. Quick challenge. What is the common denominator for these fractions? Pause and think for a moment. The next step is to write all fractions with the common denominator x times x plus 1. Step 2. Write all fractions with the common denominator x times x plus 1. We multiply the first numerator by x plus 1, the second numerator by x, and the third fraction is already over the common denominator. Quick challenge. Can you combine the numerators over the common denominator? Next, we will combine the numerators. Step 3. Combine the numerators over the common denominator. We get, open fraction, 1 times x plus 1, plus 3x times x minus 1, close fraction, over x times x plus 1. Quick challenge. Can you expand and simplify the numerator? Next, we expand and simplify. Step 4. Expand and simplify the numerator. First expand to x plus 1 plus 3x squared minus 1 over x times x plus 1. Then the 1's cancel, giving 3x squared plus x over x times x plus 1. Quick challenge. Can you factor the numerator? Next, factor the numerator. Step 5. Factor the numerator. 3x squared plus x equals x times 3x plus 1. So the expression becomes x times 3x plus 1 over x times x plus 1. Step 6. Simplify the fraction by canceling common factors. When allowed by the domain, we can cancel the factor x in the numerator with the factor x in the denominator, as long as x is not 0. The simplified expression is 3x plus 1 over x plus 1. Remember the domain restriction x cannot equal 0 and x cannot equal -1. Step 1. Write the original expression. Step 2. Factor all denominators. This makes the common denominator obvious. Step 3. Choose the least common denominator and rewrite each term over that denominator. Here the least common denominator is c times a squared minus c squared times a plus c squared. We match the first term, the second term, the third term, and now the important correction. The last term is often written missing a c in the numerator, which is wrong. The correct numerator must include a c to match the least common denominator. Step 4. Combine all parts over the common denominator, keeping the original signs. Note the second, third, and fourth terms are subtracted. To simplify the numerator cleanly, use a helpful substitution viewpoint. Let s equal a plus c, and d equal a squared minus c squared, which is a minus c times a plus c squared, which is a minus c times a plus c. Notice that a squared plus ac equals a times s. Rewrite the whole numerator in terms of s and d. Now factor out s squared. We only need to simplify the bracket. Watch the cancellation step by step. Expand each piece, and everything cancels to 0. Therefore, the entire fraction equals 0. Let's start by writing the original expression exactly. Step 1. We factor the denominator 1 minus x squared as open parenthesis 1 minus x close parenthesis times open parenthesis 1 plus x close parenthesis. Now rewrite the whole expression with that factorization visible. Step 2. Combine the two terms inside the first parentheses over a common denominator. The common denominator is open parenthesis 1 minus x close parenthesis times open parenthesis 1 plus x close parenthesis. We multiply the first fraction by open parenthesis 1 minus x close parenthesis over open parenthesis 1 minus x close parenthesis. Then we add the numerators. Step 3. Multiply this result by the second parentheses. First, rewrite 1 over x minus 1 as open parenthesis 1 minus x close parenthesis over x. Now form the product and prepare to cancel common factors. Step 4. Cancel the common factors 1 plus x and 1 minus x across the numerator and denominator. After cancellation, only 1 over x remains. Therefore, following the exact algorithm and structure, the simplified result is 1 over x. We'll start by writing the full expression, and then we will factor every denominator. Step 1. Factor each denominator. A squared minus 1 equals a minus 1 times a plus 1. A cubed minus a squared plus a minus 1 equals a squared plus 1 times a minus 1. A cubed plus a squared plus a plus 1 equals a squared plus 1 times a plus 1. A to the fourth minus 1 equals a squared minus 1 times a squared plus 1, which is a minus 1 times a plus 1 times a squared plus 1. Now rewrite the original expression with the factored denominators made explicit. Notice that a common denominator for all four terms is a minus 1 times a plus 1 times a squared plus 1. Convert each fraction to this common denominator and collect the numerators. Next, expand the terms in the numerator carefully, and then combine like terms. Expand each product in the numerator. Combine like terms. Observe the perfect cancellation of the a squared terms and the constants and part of the a cubed terms. Now factor the numerator a cubed plus a as a times a squared plus 1. Then cancel the common factor a squared plus 1 with the denominator. Finally, remember the domain restrictions. For real numbers, a cannot be plus or minus 1 because that would make a squared minus 1 equal to 0. Therefore, the simplified result is over a squared minus 1 for a not equal to plus or minus 1. The final simplified expression is over a squared minus 1. We will proceed step by step, first rewriting the parts inside parentheses into more factorable forms. Step 1. Notice that 1 plus the quantity b squared plus c squared minus a squared, all over 2bc, can be combined over a common denominator. Since 1 equals 2bc over 2bc, this becomes 2bc plus b squared plus c squared minus a squared, all over 2bc. Grouping terms, this numerator is the square b plus c minus a squared, which is b plus c quantity squared minus a squared. Step 2. We simplify the left fraction. The numerator is b plus c over a plus 1, which equals b plus c plus a, all over a. The denominator is b plus c over a minus 1, which equals b plus c minus a, all over a. Dividing these gives b plus c plus over b plus c minus a. Now substitute this simplified ratio back into the expression. Step 4. Recognize the difference of squares. The quantity b plus c squared minus a squared factors into b plus c minus a times b plus c plus a. Therefore, the product becomes b plus c plus a over b plus c minus a times b plus c minus a times b plus c plus a, all over 2bc. The common factor b plus c minus a cancels. Therefore, the simplified result is the square of a plus b plus c divided by 2bc. Square of a plus b plus c divided by 2bc. In this lesson, we will prove a beautiful algebraic identity using clean, step-by-step algebra. The expression involves 3 variables, a, b, and c, and a sum of 3 rational terms. We will show that this sum always equals 1, as long as a, b, and c are pairwise distinct, so the denominators are not 0. Here is the problem statement. We want to simplify the following sum. I'll read it aloud. bc over the product a minus c times a minus b plus ac over the product b minus c times b minus plus ab over the product c minus a times c minus b. Our goal is to simplify this expression to exactly 1. Step 1. Choose a common denominator. A convenient choice is the product a minus b times a minus c times b minus c. We will rewrite each fraction using this common denominator. Notice that b minus a equals negative of a minus b, and c minus a equals negative of a minus c. And similarly for c minus b equals negative of b minus c. Using these sign flips, carefully we'll guide the correct signs in the numerators. Step 2. Expand the numerator to see its structure clearly. We expand bc times b minus c, we expand minus ac times a minus c, and we expand ab times a minus b. Step 3. Group terms in a smart way to factor common binomials. Group b squared c with minus ab squared, group a squared b with minus c squared b, and group ac squared with minus a squared c. This grouping will reveal a common factor of c minus a and later b minus a and b minus c. Step 4. Compare the factored numerator with the denominator. The denominator is a minus b times a minus c times b minus c. Note that c minus a equals negative of a minus c and b minus a equals negative of a minus b. Thus, the product c minus a times b minus a equals the product of minus c times a minus b. Multiplying by b minus c shows the numerator equals the denominator exactly. Therefore, the entire fraction simplifies to 1. And that completes the proof. The sum of bc over a minus c times a minus b plus ac over b minus c times b minus a plus ab over c minus a times c minus b simplifies exactly to 1, provided ab and c are pairwise distinct so that no denominator is 0. This identity is a classic and very elegant result. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.